Thanks, everyone. Hi again. It's my first time being in Sofia. So far, it's been amazing. The people, the places, the culture, especially the food. I like the kebab here. It's okay, but not the best. I feel like I'm at home, so it's been a great journey for me. I'd like to thank everyone for organizing the first ever Balkan Ruby and inviting me over. Also, I'd like to thank you for coming to listen us. And today I'm gonna be talking about crystal. As you can see from my t-shirt, I'm really excited about it. And I wanted to share my journey and experience with you. So, do you know where is this place? Like, this is where I come from. It's Istanbul, and it's such a unique place. I believe it's like the center of the world. You can debate about it, but it's the only place that you can cross continents on a daily basis with a bus. Like, this is the Bosporus Bridge, and this is Europe with a mosque, and this is the Anatolian side. So for 4 years, I crossed continents, and it took like 4 hours a day of commuting. And the food. I'm pretty sure most of you are familiar with this because I learned that like you have sarma, you have baklava, you have kebab, and this is mantı, one of my favorites. I'm not sure if you have it, but it's great. So yeah, I like foods, and especially I learned that Bulgarian food is also great. About my name, it's hard to pronounce. It's Serdar Doğruyol, but just leave it. You can call me Sedo, which happens to be the combination of first 2 letters of my first name and last name, but it's not related. All my friends, my mother, my brothers call me Sedo, and that's okay. Please call me so. And my handle is this. You can find me anywhere on GitHub, Twitter, LinkedIn, and you can ping me. And this is me, actually. It was like one of the happiest moments of my life. I was presenting at RubyConf back in 2016. And obviously, I'm more fit in that picture than now. I've recently joined the Crystal programming language team as a core member. You can see me on the issue tracker like every day. And come say hi. I'm also author of the framework called Kemal, which is a web framework in Crystal. And it's pretty much inspired by Sinatra from Ruby World. I'm also the core developer, by the way. I've been maintaining it for more than 3 years. And I work at a startup called Rainforest, which is based in US, but I work remotely from Istanbul. And we do QA as a service, and you should check our website. It's pretty interesting domain. And I like learning languages, and I'm a polyglot, and it's written polyglotto, which is in Japanese here. I believe that some of you can read this already, but yeah, it's fun to learn languages. So enough of me, and let's talk about Crystal. So how many have you heard about Crystal before? Wow, that's good. Okay, we are doing a good job then. Okay. So first things first. Crystal is not Ruby, and that's certain for sure. And it's not a type Ruby 2. It's a different language, but it takes a lot of idioms and a lot of ideas from Ruby. Because Ruby is awesome, we love Ruby, right? And the thing is that in the past we branded Crystal as fast as C, slick as Ruby, but it turns out that that's kind of leading people to the wrong direction because people thought it's another Ruby implementation like Rubinius or JRuby, but obviously Crystal is not another Ruby implementation, but more like a different language from ground up. And we now call it like a language for humans and computers, which is kind of unique because there are not so many languages out there which happens to have both in common. So you might be asking why, and I have some strong proof. How many of you have seen this? So this graph explains everything back with science, like the developer satisfaction in Ruby is, getting really low, and sorry for the poor quality of the image because it's generated by a Ruby program, obviously. And I'm just kidding, just check this website. It's Ruby is that science. I believe someone had enough and obviously buy a domain and built a website just for this. And I can say that Ruby is alive and kicking well. But the real question is why? Building a language is more than just writing code, building up compilers and, other stuff. It's more about the community, the people. It's more about you, right? And so when we take a look at Crystal, the main reasons the main whys are just like this, because obviously we are here because we love Ruby. It's super efficient on human, it gives us a lot of productivity. So we want something like that. And obviously we love C. We love C's efficiency because it has really good runtime performance. We want the best of both worlds. Why not? Because we are smart. And we want the compiler to understand what we mean without having to type everything down. Types are great. You can debate that, but types are good. But specifying types are really not so Ruby-ish because we value dry, especially maths do that. And we want full OOP. And the last thing is that we don't want to write C code to make stuff faster. I'm looking at you, Nokogiri. You are taking too much. And how is that possible, actually? The thing is that Crystal is real. It's not a toy project. It's been used by companies in production. So how is that possible? The simple answer is that it's taking the ideas from Ruby and using LLVM to do the heavy work. For those of you who don't know LLVM is a compiler infrastructure, tool chain, and lots of languages actually use LLVM. Swift, Rust, Objective-C, I believe lots of other languages also, many more uses it. So it's a great project, and it's backed by big companies like Apple, Google, and so on. So the original creators of Crystal thought of, let's just take Ruby and make it work with LLVM, the idea. It sounds crazy, but I love this code. All our dreams can come true if we have the courage to pursue them. So it's just two guys from Argentina who had this idea of creating Crystal. And Crystal doesn't have any big corporation backing. It's just, some people doing this in free time. But obviously we have more resources right now. And exactly 6 years ago, Asterid, whose name is Ari, actually, who's a super smart and nice guy, committed the first initial commit with, as you can see, Lexer, parser, and visitor, which is in September 5, 2012. So it's still, you can consider it as a young language, but not so young, I think. And the thing is that 1 year later, we had the first release. Actually, the first release was written in Ruby itself because Ari loved Ruby. And you can see that all the things are actually a Ruby project. You can even see the RSpec configuration file here, the RMV file, etc., etc. So it was just Ruby. And turns out that you can write programming languages in Ruby, but It's not that fast, like, because Ruby is interpreted and you get lots of performance penalty for this. And a bit later than that, Crystal becomes self-hosted. How many people know self-hosted languages? So the concept is that self-hosted languages are written in their own languages. For example, Crystal is written in Crystal. But to make it happen, first you write in a different language, for example in Ruby, and then you compile it till the last point that you finally remove Ruby and everything else is in Crystal or in the language itself. So as you can see, this is from Crystal master branch. As you can see, it's like 98.1% Crystal. You can ignore the rest because it's mostly for doc generation and some LLVM bindings. But it's written in Crystal, so that means knowing Crystal instantly gives you the ability to read Crystal source code, which is awesome because I really love Ruby. I wanted to contribute back in the days, but learning C Ruby is hard. How many of you have tried learning C Ruby? Not so many. Because it's written in C, and I'm not good at C, obviously. So I prefer a self-hosted language. And fast forward 2 years, that's where I am coming into play, April 2015. So I was looking for something new, which had the best of both worlds. So I met Crystal, and that actually changed my life because I felt like this is it. Like this feels like home. And fast forward today, like it's been more than 3 years since I joined, but a lot of things have improved. We are not an alpha language anymore. It's being used by many companies. So let's take a look at some stats. Like we have more than 250 contributors. And that's coming from all over the world, including Japan, Turkey, Vietnam, Brazil, US. You can think of any country. We have more than 10,000 stars on GitHub. We have more than 2,500 packages. This is actually, now it's more than 3,000. Like I said, we rely on donations. So we use Bounty Source to gather donations from the community and from companies. And we are getting like more than $2,000 US per month. And we are thankful for that. So thanks to everyone who donated to Crystal ever. And we are having some tremendous growth, this year especially. And finally, we have a core developer working on Crystal full-time. Like I said, Crystal is just, people making it in their free time, or, they are doing this voluntarily. But finally, we got a sponsor to sponsor a core developer full-time, which is awesome. And we have a new release coming next week. It's 0.25. Please check it because we have so many stuff optimized and so many stuff figured out finally. And hopefully we will release it next week. Oh. And that's enough of history. So you might be wondering what's the main things about Crystal. And I'm going to give you an overview. I'm not going to go into deep dive, but you can find me after the talk and ask about anything, including the deep diving of compilers, anything. The first thing is that it's human-friendly, and that's because it's coming from Ruby. Like, Ruby is probably the most human-friendly language, as far as I know. So the thing is that this is Ruby. Also, this is the same in Crystal. Like, this is the simple statement that you can run, which prints hello world. So this is super friendly to anyone. And this is also pretty simple. This is fully fledged HTTP server with static file built in using Kemal, which has like, if you require 5 lines of code. So this is also pretty human-friendly. And on top of that, we have a real type system, actually strongly typed, unlike Ruby. But the thing is that it looks the same, right? Like, you can see that there are no types here. And we have a char, yay. Like, if you use single quotes, it's a char, and if you use double quotes, it's a string, end of debate. And yeah, as you can see, you don't specify types because Crystal is compiled. We have a really smart compiler which infers the types. And if you want to check the types for real, I mean, you can ask, are they there? Yes, there are. And you can see it like with type of, which gives you the compile time, type of the variable. As you can see, this is a char string, int 32. We have real integers like int 8, 16, 32, 64, and now we are implementing 128-bit integers too. We also have floats, and this is the most interesting type, and this is called union types. And you can see that the type of the array is the combination of all possible types inside, and this makes it feel like it's a dynamic language because normally in a compiled language you have to specify the type of the container. But in Crystal, most of the time you don't have to because the compiler is pretty smart. And let's talk about union types. Union types are like the best feature of Crystal maybe because it feels like it's the missing thing in the previous compiled languages. I mean, some languages have those, but not the big ones. For example, consider this expression here. If 1 plus 2 equals 3, A is 1, else A is hello. So you might be wondering, I mean, if you take a look at this code, you know that it's 1 and it's an integer, but the compiler, since when it's compiling, doesn't execute the expression, so it has to give all the possible combination of types as a type. So you do that by union types. As you can see, it's int 32, and the pipe operator means or string. And the thing is that union types are pretty flexible. You can have as many as you want. The compiler optimizes it and uses the most efficient type to hold the actual data. And when you take a look at the runtime class with class like you do in Ruby, it's just int 32, the return value of the expression itself. And the other great thing is, I mean, which I really like, is the method overloading. How many people have used method overloading in any language? Okay, cool. So you know the idea. So method overloading eases up a lot of stuff. Like in Ruby we do this a lot, right? So I hate this. Like you just do a sweet case statement and then you just check different types. But this is cumbersome and this is really hard to manage after some time. Instead, we can just do it like this in Crystal with method overloading. So you can overload the method with different type signatures. For example, if you want to overload for my class, you can just specify it like this after the column. And then if you want to overload this for array, you can just redefine it for the array type signature and for string and so on. And when you are calling the method, you just pass the appropriate type and the compiler infers it and calls the correct method with the correct type signature. And if you don't want, I mean, if you handle the else case like you would do in a normal scenario, you just don't specify the type and the compiler knows that it's another type that doesn't fit into these overloads. And at compile time, Crystal generates different methods for this. So, yeah. This is also very interesting, like null reference checks. And I'd like to ask you a question, or to put it simple, how many of you have this pain every day when writing Ruby? Like, it's the most common thing that we are, getting pain from. It's because we are lazy and we don't check nils mostly, and we have tries and all that lonely operators, which is totally unsafe. Yeah. And in Crystal, for example, can you see that there is a problem with this code here? Like, the problem is that rand2 actually can give you 0. So that means 0 is not greater than 0. So that means my string can be nil, right? If it was Ruby, this is gonna be obvious, or can be a nil exception. Because if you try to call upcase on nil, you are just gonna get an undefined method upcase for nil, right? But in Crystal, we have a compiler and it's good. If you try to compile this, like Crystal and the file name, you will get a compile time error that's undefined method upcase for nil. And it tells you that the possible types are either string or nil. So in Crystal, it forces you that you have to handle nils. Otherwise, it's not gonna compile, which is good because you know this beforehand. You don't gonna get some runtime errors afterwards. The way of doing metaprogramming, not all, but I love metaprogramming, especially when I learned about send and evals in Ruby. I was like, wow, this is great. I can do whatever I want. But it turns out that that's not good. And in Crystal, we have something called macros. It's the way to do metaprogramming. But the difference is that it's at compile time, so there's no performance penalty. Oh, God. Sorry. And as you can see, you just use the keyword macro. For example, this macro is named define method, which defines a method for you with name and content. This is like just pasting code for you, but the thing is that these things are AST, so you can do some interesting stuff with them. You can evaluate them later, or you can just, escape them, whatever. And if you call this define method macro, it will generate a method for you, and then you can just call that method like you would do. So this is pretty much similar to define method we have in Ruby, actually. And you can do this in compile time, meaning that if there is a syntax error or any weird thing happening with the macro, you will get a compile time error, right? Which is great. And we have monkey patching, aka open classes. Some people don't like it, some people do. I like it. Like, you can do something like this. You can just open the class and define a method like you would do in Ruby. And again, no performance penalty for this too, because obviously it's at compile time. And the great thing is that we have built-in concurrency in Crystal, and we use something called fiber, which are actually green threads. And it's actually the idea is coming from Go and Clojure. Like, it's cooperative, and it doesn't use shared memory, or it doesn't use something like threads. It uses message passing. Actually, the idea is called CSP. I'm pretty sure some of you know this from Go. And the thing is that it's pretty much the same, like the reading. So we use channels to pass messages between Spawn. I mean, Spawn creates a fiber for you in the background. When you use Spawn, it just executes code asynchronously, but obviously, if you want to get the result back, you have to use a channel and then pass it through the channel. And to read that from channel, you can do channel receive, and that's it. And the thing is that channel send and channel receive is blocking. It blocks the main fiber. Actually, in Crystal, the main program is also a fiber. So you have to make sure that you are sending and receiving correct times. Otherwise, your process is going to get stale. As you can see, this is a concurrent total lines reader from a directory, which reads all the lines of TXT files concurrently and just puts out. And the thing is that currently this is not multi-threaded. It runs on single thread, but the thing is that Crystal uses an event loop, so it's pretty fast. And one also interesting thing is that native code. So the thing is that when you use Crystal build, it just builds the native executable single file for your platform. So if you are on Ubuntu or something, it just builds an ELF executable. If you are on OS X, it just uses Darwin compatible stuff. And the thing is that we have an incoming Windows support, so you can just use Crystal build and get an exe like this. But obviously it's not finished. I mean, you can compile some programs, but currently we lack some time support and file support there. And PRs are welcome. Please join us. We also have C bindings, which makes things interesting, because we don't have to use C to actually call C, unlike Ruby. So you can see that this is actually taken from Crystal's source code. So we have a bigint, and this is the simplest bigint implementation in Crystal. So we just use libgmp, which is a great library and which is already written in C. So we just use the link annotation here, and we give the library name. Actually, it searches through the system path, or you can give another path if you want. It has a lot of options. And you just use the lib keyword, and you can alias types like libc int, libc long to whatever you want. And as you can see, you can bind structs and functions, C functions to Crystal functions, and then you can just call it like normal Crystal code here. And this is pretty good because it really takes away the pain of dealing with C code. For example, one of my friends created PostgreSQL binding in really short time because it's just, you know, a single line of method definition, and that's it. Testing. We all love testing. Like, we had great talks here about testing. And the thing is that, how many of you have used RSpec? Cool. I love RSpec too, and we have something called spec, as you can see, which is built in. And it's pretty similar to RSpec, but it's more plain. So we don't have context, we just have describe blocks. For example, this is also taken from Crystal's array implementation spec. So as you may already know, Crystal is written in Crystal. So the specs are in Crystal too, and you can just read the source, right? For example, the size test is just, you know, this. And you can see that there are also helpers like be true, be false, and many more. And you can just test like you would do in Ruby, which is pretty nice. And we have, I mean, in Ruby we have gems, in Crystal we have shards. So this is how you add a shard to your project. It's in YAML format, and when you create a new project with Crystal init, by the way, Crystal has this init command built into itself, so you just do something like Crystal init app, and it will generate the boilerplate for you, including the shard YML file. And you see that you can add Kemal like this. And the thing is that we don't have any central repo for shards. It just fetches the dependencies from GitHub or another Git source or SVN. And to search on other shards, we use something called Crystal Shards XYZ. It's an interesting domain. And you can search for, trending, popular, or anything you want. And as you can see, this is taken like today or yesterday. We have like more than 3,000 total shards. And these are at least updated like in the last year or something. And it's really increasing in a steady pace. And more awesomeness, like yesterday I talked at the panel that there are some small stuff which can make Ruby. In Crystal we have some kind of small stuff, but it really, gives you some pleasure. For example, we have something called Crystal Play, which is built into, so you get it when you install Crystal. So it's just an interactive playground in your localhost that when you type Crystal Play and go to localhost 8080, you can just, play in the playground. I would actually like to demo this, but my PC is not working, so I don't have Crystal here, sorry. And the other goodie is that I really like this Crystal tool format. So Crystal has this, so you can just format your code when you autosave your file in Atom or Sublime or VS Code, which is pretty cool. And I really miss this in Ruby. Also, end of the most, redundant byte sharing in Ruby world is like double quotes or single quotes issue. We only use double quotes for strings, and that's it. Pretty simple. And the thing is that Crystal actually speaks proper English, so we actually have includes, not include, or many other things that's found in Ruby is corrected. And yay for this, I really like this. We don't have global variables. So in Ruby, global variables are like evil because mostly they lead to data races and it's really hard to debug them. And we ditched them. Like I think it's like 1 year or 2 years ago that we made this decision and just removed all the global variables. So instead we use classes and some kind of static variables to actually hold global stuff. And you might be wondering, does anyone actually use Crystal in production? The answer is that yes. I mean, it may sound a bit crazy, but this is taken from Crystal Wiki. You can find it on GitHub. So there are lots of companies actually. It's growing rapidly. Maybe we have like more than 30 companies right now. But the interesting thing is that we are not just being used by web domain. So we have cybersecurity, AI, ML companies using it. We have a really interesting company. I'm not sure if it's here. Let me see. Nope, they are not here. But there is a company called Diploids, and they are doing some DNA analysis and genome analysis stuff with Crystal. And they say that previously it's written in Ruby, and now they say that it's like 10 times faster in Crystal. And they're actually using that in production, so people actually get their cancer scanned by Crystal code for real, which is pretty cool. And the other thing is that performance. In previous presentations, I would show benchmarks, but I I decided that it's not a good idea anymore. Instead, I just show some real use cases. So this is me, obviously. And the things that I joined Rainforest QA, and we started kind of looking at existing projects and how we can improve them. So we had this service which is like crucial to us, and previously it was in Ruby Sinatra, and we had like more than 700 MS, 99 percentile, and I rewrote that in like half a day in Crystal and Kemal, and it just works like now in 15 MS, 99 percentile, and this is not, the graphs are not good, but the memory consumption and the response times are here like dropping rapidly, significantly. The memory consumption was like 100 megabytes in Ruby, but after switching to Crystal, it just turned into non-existent. Like it was something like 2 or 3 megabytes, and it was consistent. So the garbage collector was doing a good job, obviously. And then there is this one. This is actually not done by any Crystal team or any Crystal member, but more from something called Tech Empower Web Framework Benchmarks. And here you can see that on top we have a Crystal framework. It's Kemal, and as you can see, it's pretty much on par with other languages and other frameworks from Go, Lua, and Haskell. So you can say that it's doing good, even though it's single-threaded. Fibers are really lightweight, and they can do some impressive work, as you can see from here. And this Fortune's benchmark is mostly CPU dependent, so that's a great thing. And the result is that, I mean, Mats called this, I mean, like in last Ruby Kaigi, he called Crystal deliverance. Maybe he was joking, but I believe it's some kind of deliverance to Ruby community. And let's take a look at resources. For example, we have the Crystal book. It's located under Crystal Lang docs. We have Crystal for Rubyist.com. It's a small book that I wrote like 2 years ago. It's free. It's like maybe 50 pages or something. It's free in PDF and Kindle and many other formats. Just go and download it. It takes like 1 day to read from top to bottom. It's pretty easy. We have our Gitter channel. We have a really active community in Gitter. Like maybe we have more than 500 people. I'm not sure, but it's growing. You can check the Kemal website, kemalcr.com. And I have stickers here, Crystal and Kemal stickers. And does anyone know what this is? Fez? Yep. Cool. So it's not a book, it's a fez. It's a traditional Ottoman thing. And lastly, I'm writing a book about Crystal. It's called Learning Crystal Programming. It's still not finished, but I'm working on it. Hopefully, I'm gonna get it done soon. And writing a book is hard, obviously. And thanks everyone for listening, and please feel free to ask anything.